Welcome again to day 2 of IMX 2020. My name is Frank McCormick, and I'm the Gulf Coast correspondent for the Waterways Journal. Thank you for being part of IMX and for this session, which is titled Tier 4 Engines and Supply Chain Update. Before we get started, I want to stop and thank all the speakers, sponsors, and exhibitors who have worked so hard to make IMX a success. All of them, along with you, the attendees, have come together to make this, which is our 7th IMX, a great success so far. Thank you. Just a few things before we get started. Be sure to visit the virtual expo hall, which is live today until 4 p.m. and again tomorrow from 10 to 4. There's a lot of outstanding information there and plenty of opportunity to network and make new contacts. Also spread the word among your colleagues and companies. Registration is free and anyone is welcome. Also, be sure to look over the education schedule that remains, and don't worry if sessions that you're interested in overlap or if you missed anything that you're interested in, because this session, along with all the others, will be recorded and available very soon, and they'll be available through Thanksgiving. For this session, feel free to use the Q&A panel to post any questions that come to mind for our panelists. They'll answer them in turn. And now it's my privilege to introduce you to Mr. Jim Munt with Caterpillar Marine Power Systems, who will moderate our session today. Thank you, Jim. Take it away.
Thank you, Frank. And good afternoon, everyone. We are very pleased to have this session and this opportunity to do some sharing on the Tier 4 engines and the supply chain update. This is actually our third year now of the implementation of Tier 4. There was a lot of progress that has been made, a lot of successes. I'm very excited to participate in these sequences and to provide the progress and update for everyone. I'm also very happy to be joined by an esteemed team participating on the panel today. First speaker, we're going to have Mr. John Burton. He's a senior applications engineering specialist, product specialist with Caterpillar Marine. The second speaker will be Tim Peters, who's a marine applications engineer with MTU. And our third speaker is going to be Richard Kalaga. He's the manager of business development of EMD Commercial Marine Engines, part of Progress Rail. And then we will move on into the supply chain update. And first off, to cover the progress being made with the logistics and the supply of DEF fluid along the river systems is going to be Mr. Tony Odak. He's the vice president of John W. Stone Oil Distributor. And also then lastly, we're very proud to also have Mr. David Reynolds, Vice President of Economy Boat, also to share some of the support logistics and progress being made along the rivers for midstreaming and support of diesel exhaust fluid deliveries. So without further ado, I am going to hand this presentation.
So welcome, everyone. I'm just going to go through this real quick. So on the diesel engine side for EPA Tier 4, we, as a diesel engine manufacturer, we have a couple of different technologies that we can use, different strategies or combination of strategies that we can use to achieve EPA Tier 4 limits. So on the slide in the blue, you've got on-engine technologies, and in the lighter blue, you've got off-engine technologies. So on-engine technologies would be something like the engine timing, the Miller cycle, turbocharging, fuel injection system, where you can increase the fuel rail pressure to help with atomization of the fuel and particulate matter, getting rid of that, solving that in engine, in cylinder. You get exhaust gas recirculation, engine and SCR controller, or as the industry knows, a closed loop system, or combustion optimization. That's all on engine. Off engine or behind the engine, you've got options like oxidation catalysts, diesel particulate filters, or SCRs, or selective catalytic reduction. So for the purposes of this presentation, most of the market is moved towards SCR technology, so I'm going to focus on that. So the benefits of combining on-engine technologies with an SCR behind it. So with these on-engine technologies, when you combine these different strategies here, you can reduce the hydrocarbons in the cylinder in the combustion chamber to the EPA Tier 4 limits. You can reduce the particulate matters to Tier 4 limits. You can reduce oil consumption, improve fuel consumption through increased a better specific fuel consumption. That comes at a strategic increase of NOx. So we've all decided we're going to handle NOx after the engine within the selective catalytic reduction. So the SCR technology behind the engine is the penalty in NOx can be easily offset with the SCR system, as discussed before. There's an integrated closed loop controller that monitors the NOx in, NOx out of the system, and can adjust the DEF dosing. And the engine and SCR controller allows all of these technologies to work at the most efficiency levels. So you're not exactly blind dosing, if you will. So most importantly, I think from the perspective of the customers out there or someone that's new to EPA Tier 4 technology, wondering how this new technology is going to impact them, I've created a couple slides of the considerations and the benefits. So operator considerations. It's no secret. The SCR technology after the engine, it requires a larger footprint, footprint for the overall propulsion package and tankage and specialized tankage, climate controls, those kinds of things. So this all has to be considered in the design phase of the project. It requires increased ventilation because the SCR rejects heat, so that you have to do an analysis on the volumetric air flow through the engine room and make sure that's taken into account. In some cases, air versus airless dosing. If you're doing air dosing, you need a larger compressor with clean air in order to make sure that the system functions properly. This could result in increased cost and space claim for a larger clean air compressor. Just needs to be taken into consideration during the design phase. There's additional maintenance with this new technology, so there will be some increased costs to the operator in the life cycle cost studies. And now there's a little bit more administrative work because the EPA requires delegated assembly tracking of these components as they make their way into the marketplace. So the benefits is that the base engine remains fairly the same. The diesel engine that you used to see in the past for Tier 3 looks very similar to the diesel engine for Tier 4 if you're using SCR. The fuel system could be a little bit different. There could be some small changes here or there, but for the most part, it's the same foundation. So it also allows for the best fuel consumption throughout the performance map because you can tweak the specific fuel consumption and the internal combustion because the NOx will be offset after the engine. But of course, there will be costs associated with DEF consumption. The SCR system reduces some exhaust-borne noise, and it can minimize the muffler size that's needed. You may only need a pancake muffler after. So there could be some potential savings where you don't have to have a larger muffler with a large space claim in a stack. There is little to no impact on transient performance, so you'll still experience good engine acceleration and low-end torque. The SCR allows the use of various sulfur fuels around the world, and this is a pretty important one, considering that some of these vessels move throughout various parts of the world, and you never know what kind of sulfur content you're going to get in your fuel. So it gives you some operational flexibility. And the engine can still operate if the SCR fails. So this is a benefit from a reliability standpoint. So those are the considerations and benefits for this technology. And just to give you a little idea of the space claim of these types of systems, here's a profile and then some renderings of some systems that have been designed into different vessels. And the population of this Tier 4 technology is every day grows a little bit more. So here's a small sample of boats that are currently running with Tier 4 technology. So the more boats that are running, the more hours that we accumulate, the more knowledge we gain, and I think that's a good thing for the market as a whole. So thanks, everyone. I just want to turn it over to Rich at this point, but thanks for giving me the time.
Richard, are you able to drive from your side, or do you need me to help you?
Can you drive? Would you mind driving, Jim? There you go. Good afternoon, everyone. Glad to be here with you today. I'm going to give you a quick update on the EMD Tier 4 solution. Okay, so by way of background, before I go into where we're going with Tier 4, I just wanted to give you a little bit of background on how we've gotten here. We've been guided by these three acronyms that we've committed to long ago, and they're all voices of you out there, the stakeholders when it comes to EMD engines, or excuse me, with Tier 4 engines. Obviously, customer comes first. We want to make sure that you always have the highest possible uptime, lowest OPEX, lowest CAPEX. And from that second bullet point, from a service and maintenance point of view, we need to keep it as easy for your crews to understand and to maintain as possible. And we don't want to compromise on the engine performance that you're used to from Tier 2 and Tier 3, because we equate transient response with operational safety, maneuverability. And I already touched on that, touched on the third one, but it has to be as easy to operate and service as previous engines. And as you'll see, it's actually the tooling and the construction is very similar to several generations back, not just the most recent generations. From the shipyard point of view, we understand how critical it is for you to maintain control of your costs, to make it easy to apply to your vessel designs, from an engineering point of view, and easy to apply to your ships from a construction point of view. And the same thing with designers. We don't want to give you a million different variants of how to do something. We want to try to standardize on one approach or a small set of approaches, minimal set of approaches, so that your engineers can quickly apply the design to any number of vessel designs that you're working on. Move on to the next one there, Jim. So as I alluded to, you could see that the current model, Tier 4, on the right side of the slide, it's an evolution of an existing design that goes way back to the Series 567, which is historically significant back in the World War II days of landing ship tank vessels. So it's been a constant improvement process rather than designing something new from scratch. We understand that the industry is not always very welcoming when it comes to radically new technology, so we take the continuous improvement approach to maintain your confidence. There you go, Jim. On to the next one, please. So by using that as the background for the discussion here, the previous generation engines, the largest portion of the population that's operating on the lower rivers, on the U.S. inland rivers, lower Mississippi, upper Mississippi, Ohio, and other tributaries. Relative to those older engines that are 30, 40 years old, today's Tier 4 engine consumes quite a bit less lube oil, on the order of 60% than those older engines. Their earlier designs. We've come up with kits to help reduce that, but using the original lube oil consumption of the original engines, that number is quite large. Double-digit reductions in fuel consumption as well. And the transient smoke is also much lower than the predecessor engine because the turbocharger moves more air, relatively speaking. We've increased the output that back in the 80s with the original 710 engine, and today's evolution of that engine moves a lot more air, and so you get that transient response with a minimal exhaust opacity. And so, as easily understandable, we have Tier 4 certification. So that means we emit very low levels of NOx and particulate matter below the regulated standard, and do it with less smoke and without compromising that transient response. Okay, Jim. All right, so here's what that transient response looks like from a performance point of view. I'm not going to dwell too much on this because it gets a little too technical, but you can see the dotted line on the propeller curve dotted line there. For those of you who are familiar with marine engineering and marine propulsion, that's the anticipated ideal demand line that fixed pitch propeller vessel climbs, and most vessels operating today on the inland rivers are fixed pitch. So maintaining the ability to climb up that fixed pitch curve in less than, you see there, 13 seconds, that's still a leadership position. With the SCR approach, I believe I speak for my Caterpillar colleagues as well, using their approach to the dosing control system and to the SCR approach, we're able to maintain the transient response while reducing NOx, which in many other cases, reducing NOx using other technologies such as EGR actually comes at the cost of transient response. So we've maintained that going forward. We've maintained that superiority going forward with Tier 4. Next one, Jim. And since hybrid is becoming a common discussion point among us all in the industry, we're all trying to find ways to reduce emissions and to work with flexible powertrain systems. High transient response is also a benefit for diesel-electric solutions as well, whether constant speed or variable speed. An engine with very quick transient response is a favorite of electrical engineers and designers that engineer these hybrid systems, because whenever you have a transition from one power source to another, the faster it can respond, the more transparent the operation is to the pilot. So you can see here that we've maintained that ability to take full block load, full 100% load when the engine is spinning at 900 RPM in an absolute emergency. Then the engine can take 100% load without breaking it up into small portions. So maintaining those keystones that I described earlier, this is what we built on for Tier 4. So now it's an evolved version of the existing product. It's an improved version of the existing product. The SCR enclosure that you see, that cube that's just to the right of the engine, that is our patent. It's our own package. It's something that we designed in-house to fit into the tightest of tugboats going back to 2015. So tugboats that were originally designed for Tier 3 engines. And so using that small size enclosure, relatively speaking, for a medium speed engine, and then using Caterpillar's closed loop dosing control system, which looking at the pictures that Tim Peters showed earlier, many of those Caterpillar powered boats, the dosing control systems that are in those Caterpillar powered boats, we're using the same exact system. So there's commonality building across the fleets there as well. So from just dissecting this a little further, the application of the system is very easy. We tried to make it a plug and play at the same time, making it as turnkey as possible. So the 1, 2, 3 bullet points there, the balloons there indicate the order of installation. So we would install the engine first, then the structure beneath the SCR, which we call the accessory rack. It's a very stout frame that rests on the engine bed frame. It contains, just for space saving reasons, it contains some engine accessories like lube oil cooler, lube oil filter, thermostatic valves, so that those don't have to be located within the engine room somewhere. And then the SCR is bolted down to that. So the shipyard doesn't have to worry about how to mount the SCR, how to react to it, whether or not it's going to affect vessel stability by installing it way high up. And we supply item number 4 as well to interconnect the engine to the SCR. That's actually a mixing tube. So the DEF is injected into that mixing tube, and then it goes through that SCR. It's a kind of a labyrinth flow SCR. It's not just a straight through kind of a flow path. And so there's a lot of benefit to this when it comes to, installing a Tier 4 medium speed engine into a vessel, into a workboat. For one, there's flexible exhaust outlets. When you look at the top portion just above the number 3 there, that's already cleaned exhaust gas. That's already gone through the catalyst, and it's ready to exit to the atmosphere. So that enclosure has the flexibility to apply any number outlets in numerous directions, I should say. So we've used pretty much in all the vessel references that we have so far, I think we've used every return point from that SCR. And we've also added closed crankcase ventilation system, which is a new feature for medium speed engines as well. That basically means that any kind of crankcase vapors that in the Tier 3 days were vented out to the atmosphere, now they're being actually filtered even further and then re-ingested back into the engine for oxidation either through the cylinders, and then whatever doesn't get oxidized through the cylinders actually also a significant portion of that gets oxidized through the SCR. So the particulate matter emissions from our Tier 4 engines are very, very low as well, without having to resort to a diesel particulate filter. Okay, next one, Jim. And you can see here the 3 most common engines that we have on the rivers, the 8, the 12, and the 16. So if you want to equate them to 2,000, 3,000, and 4,000 horsepower, unrestricted continuous power at 900 RPM, they all use the same size, the same enclosure. The only thing that would cause a variation between any of these is where you choose to take the exhaust out of. You could see 2 potential connection points for your offtake on those SCRs there, but there's also 2 others that run parallel to the mixing tube up there to go aft if needed as well. Next one, Jim. These are our vessel references so far with Tier 4. We're very proud to have won business from these customers who have trusted us with their operations. Bouchard Transportation, our petroleum ATBs, 4,000 horsepower, 2 8-cylinder engines. Our very first Tier 4 delivery several years ago was for the Washington State Ferry MV Suquamish, and that one has been operating since 2017. Staten Island Ferry is, you probably have seen videos and press releases of them launching the Alice class ferries there. So those have not entered service yet, but those are underway at the shipyard. On the right side, before I go to the bottom of the 12 cylinders, on the right side, we also have a historically significant new build with 16-cylinder Tier 4 engines for Interlake Steamship Company. It's not Inland River, it's Great Lakes operation, but I wanted to point it out because the customer was very strict on transient response requirements and the emissions requirements, and we were very pleased to have earned their business there. I'm going to highlight our references with Canal Barge. You can move on to the next slide here, Jim. The H. Merritt Heavy Lane Jr. is our very first Tier 4 reference on the rivers, and it's the very first EMD Tier 4 engines in operation on the lower Mississippi River. Again, we're very honored to have earned Canal Barge's trust for this project. Canal Barge did a lot of research into the appropriate power for this project, and we were very, very honored to have won it. It's a traditional fixed pitch propeller drive, so all the merits that I explained earlier that we tried to preserve with the previous engines, we believe those added value for our value proposition here for the Heavy Lane. It's their flagship vessel, and as far as I understand, I believe these are the only medium speed Tier 4 engines operating on the lower Mississippi River. So we've been helping Canal Barge move tonnage since 2003 with Tier 4 ultra clean power, knowing that I believe the other medium speed Tier 4 engines that are out there on the inland rivers, I believe they're operating on either the upper or the Ohio rivers. So it's a proud distinction for us to have that today as well with Canal Barge. So where do we go from here? Where have we been going towards with the technology fairly well defined, fairly well accepted? We've been communicating the information on the solution for several years now, and we've taken input from industry on how to further improve it. On the engine side, it's essentially the same engine, just improved. It's that constant improvement approach with reducing lube oil consumption to make it work better for Tier 4. There are obviously additional diagnostics to talk to the after treatment system, so there's some additional operator training happening there, but no major structural changes from the predecessor product, which is, I believe, again, a benefit, because your tooling is largely the same for servicing the engine. Understanding how the engine operates, troubleshooting it is unchanged. Moving to the right side of the slide here, this is where the focus has been from a training and diagnostics and the technology understanding, technology comprehension point of view, is knowing that we're leveraging our being owned by Caterpillar. You can see the footer of my slides there. We are a Caterpillar company, leveraging their not just their products, but working together on understanding how the products should work to meet our customers' needs. Providing the diagnostics and training support on the after treatment system, teaching crew and port engineers how the system thinks, how the system works, and anticipating what other kind of needs, whatever other kind of actions need to be taken. That's been the main focus of our work, of our service managers' work to date. And in the slightly longer term, we can move on to the next slide, Jim. In the slightly longer term, I say slightly longer term because this is on the horizon, is actually we're taking a bit of a reverse approach. And that is that we started out with an integrated package that's all plug and play, but now we're working with shipyards and with naval architects and end customers on applications where the engine room is too tight for both of the SCR and the engine in there. So working with them on properly applying the SCR to remote locations. And so whether that means us just verifying pressure drops from the engine to the SCR, or actually having our engineers do a computational fluid dynamics simulation that helps us understand the DEF vaporization and the distribution through the catalyst, everything that's needed to make sure that the shipyard and the naval architects and the end customers have the confidence that the system will be fully compliant with EPA requirements. And so there's an additional innovation that came from that, being able to service the SCR from either side and not having to service it from each side. The enclosure that you see on the left, previously, that can only be serviced on each side. You had to take out half the catalyst. If you needed to replace the catalyst, you had to do half from the right bank side, or half from the port side, half from the starboard side. With this new innovation to the right of the arrow, now you can, regardless of which side you're on, you can fully service all the catalysts from one side without having to do both. And that's in a nutshell. That's a summary of what you've gone to.
Thank you, Rich. Very much appreciated. Now, John Burton, are you able to join us on phone?
I hope so. Can you hear me?
Yes.
No, it's good. So I can, kind of carry on some of the message. When everybody hears after treatment, it's panic. We don't want this. And so just fast forward on just to slide 3, Jim, and I'll start right there.
Okay. We're on slide 3.
And so, so the feedback we get, this is too big. We don't want this thing. We can't get DEF. And so, you've heard all the technical presentation from the guys here. So, we're all using similar technology. And what we did, we took this message out to the field. We went out and we talked to the naval architects and the customers and the operators. And the naval architects and the ship designers, builders, they take a look at these and said, okay, this doesn't look so bad. We can work with this. And, at the end of the story, when some of these boats are out here running, the feedback we get, this SCR stuff, it was no big deal. So, the message is it's tried and true technology. It's been around since the 1950s. It's proven and simple technology, fairly easily to install. So forward, Jim. We went out and we talked to all these people, talked to the naval architects. We took our technical team to talk to your technical teams out there. We brought some of our factory engineers to the job sites. We did a lot of teleconferences with naval architects to go over what we call the virtual design review. So we were more or less remote consultants on some of these designs. How does the engine room look? Are these components laid out properly? We can't fit this. Is there anything we can do? So we worked directly with a lot of the shipyards and the naval architects to make sure these installations went well. On-site support, remote support. Maybe a lot of people on the phone. I was at your site. So forward. And here we are. So we've got widening acceptance of the Tier 4 product, the IMO 3 product. Obviously, in the U.S., we're governed by the EPA Tier 4 guidelines. So, but a lot of projects, successful projects on all of the coasts, starting to gain a little bit of traction on the inland rivers, as your Rich and Tim pointed out. There's also some rapidly acceptance of this and rapid growth to meet IMO 3 regulations, primarily in Europe, to meet those inland waterway requirements over there. We're seeing SCR systems show up in yachts, tugboats, dredges, offshore supply boats, and as you expand outside of the regulations that govern for Tier 4 into the IMO 3, which encompass power less than 600 kW, for example, the dots on this map just explode. So, one more, Jim. And so, we're all here to help you be successful in your projects, give advice. Rich commented that he had engineers on site. Tim's talking about technology. So we're all here to help you design these, help you, guide your designers, be there to help these projects be successful. So my message, reach out, come talk to us. We're here to help.
Thank you, John. Now we're going to transition to our midstreamers, or the supply chain side of the panel, and Mr. Tony Odak, if you could drive now and share, appreciate it. Thank you.
Well, good afternoon, everyone. Can you hear me?
Yes.
Okay. Thank you, everyone, for attending. Thank you for the panel. Thank you for Workboat and IMX for putting everything together. As Jim had mentioned, I think this is our third year doing this, and things have slowly but surely have progressed. I just threw up a few of the suppliers out there we had recently talked to in the past that had the ability to supply, and this is pretty much concentrated around the inland river system. It expands outward as we go to the Gulf Coast, the East Coast, and West Coast. So. But I just wanted to kind of give you a little picture of who the midstreamers are that are supplying out there. You may wonder, who Stone is. Knowing who Stone is, or if you don't know, we're a fairly sizable fuel supplier on the inland river system. That being said, why would a midstreamer who's in the fuel business want to get into the DEF, or sometimes we'll call it urea supply business? Well, I used to say that that is where the industry is going. Well, I'm happy to say that that's no longer where the industry is going. That's where the industry is. For years, you'll see some slides a little bit later that, we went from initial supply, initial fills, and some foreign vessels that needed the use of IMO. IMO came into compliance well before the EPA Tier 4 engines did. We were able to supply that and build a supply chain. But Stone, did not wait on the supply, the chicken and the egg scenario. John Stone Jr., the owner and of this company, decided to roll the dice early and go out and build urea-ready equipment and suitable equipment. We were fortunate to get in on that market early, and as you'll see at later slides, what has developed over the years. So as we go on to the second slide, question is, what is urea? So urea is diesel exhaust fluid. It's really purified urea with a specialized water. In years past, there have been a lot of folks that have gone out and gotten fertilizer grade urea and tried to blend that with tap water. Well, big no-no. I gave you just a few examples. Rich and Tim and some of the other folks have gone through, and John gone through the the process. I'm not going to dwell on the process, but to tell you that it is a very specialized product. Is there concern that you could contaminate everything? Absolutely. It's got to be handled in the proper way. We're going to show you a slide in a minute what it is, but those are kind of some of the pictures of people that were using product that really wasn't certified, wasn't a quality delivered, quality supplied product. So urea typically comes, or DEF typically comes in a 32.5% grade and a 40% grade. The only difference is the density or the concentration of the urea in the product. There's some operational issues that need to be resolved, but from our conversations, maybe it can be asked between all the OEMs, but our conversations with the OEMs has been that you can't intermix the 32.5 and 67, or excuse me, the 32.5 and the 40%. So I'll go on to the next slide. With regards to the contamination from non-compliant urea, you can see it doesn't take a whole lot of contaminants to contaminate that. One of the biggest requirements is stainless steel holding tanks. We're going to get into some question and answers, and y'all welcome to ask a lot of questions. And believe me, many of the questions have already been asked, and if they haven't, we'll welcome to field any new ones. But the small amounts, if you could take a look at 4,800, a small tanker load, road tanker load, what it takes to contaminate that. I mean, literally from a tenth of a teaspoon of copper, to nearly 2.5 teaspoons of potassium, or 2 teaspoons of sodium. So those little amounts are enough to contaminate that. As a visual, we've got some samples out there. Just as a visual notation, by no means is that the only way to take a look at it, but you should be asking for certificate of quality, much like you'd be asking for a certificate of quality or certificate of analysis on your fuel. You ought to be taking a look at and asking for a certificate analysis on the urea. Again, there's always been the concern of what's the handling protocol and the PPE requirements. So as an overarching comment, we've been delivering urea, we've been delivering DEF in the marine system, in the maritime field since about 2011. I'm going to tell you what I tell our truck drivers. Use the same precautions you would when handling diesel. If you feel you need to use gloves, use gloves. If you feel you need to wear face mask or eye protection, absolutely, we encourage it. But it's not something to be afraid of. I mean, in past presentations, Jim and some of the other guys have been involved in, you've seen me pour the 40% urea on my hand and you wash it off. There's some cute anecdotes that I've got for you, but are not so cute and a little bit disgusting anecdotes that I could share with you offline, but is not something to be fearful of. Some of y'all are dry cargo haulers. One of the dry cargoes out there is urea, is fertilizer. Treat it like fertilizer. This is the basis of it from a 50,000 foot view. Is it's a fertilizer. It's fertilizer it's a purified fertilizer with purified water. If you're not afraid of handling that urea fertilizer, then you shouldn't be afraid of handling this stuff as well. And I'm going to head over to my last slide and kind of summarize what we've been doing. As Richard mentioned, we did the initial fill of the heavy lane, and several of the BSO boats. I mean, we've been involved in this since 2011. 2011, we did the icebreaker and supply boat, the ECO Ivic, and she was, I believe, Caterpillar Tier 4 engines early on with a SCR, went and operated up in Alaska. We did the initial fills and we did subsequent fills. Since then, because of IMO requirements, Stone has been doing quite a bit of supply of the 40% urea to ships and the ship requirements. We've had the capability from back in 2009, as I'd spoken earlier. We built the barges, pre-built barges with flexible capability that we could take. If you can see that middle picture with the green tanks, those are one series of barges that we modify to have stored the urea in bulk. Subsequently, depending on what the customer demands, we've gone from that model to, in the lower left-hand side, you see a model which has got dedicated stainless steel tow tanks and pumps and accordingly. So we've kind of, even though we've made the investments in bulk equipment, we've also made it variable where we can pull on, add, and subtract delivery capability. And again, not only are Stone supplying, and I think Dave is going to talk about supply locations in his presentation, but not only are we supplying in the Gulf Coast on the lower rivers, but we've been managed to do some trading and some brokering. We've assisted other suppliers both in the Gulf Coast, on the West Coast, on the East Coast in supply, not only obtaining supply, but walking them through. Stone was on the early end. We went, because we did those barges back in '93, we met with the Coast Guard, we met with the regulatory bodies in order to meet the requirements for urea storage and urea delivery. We'll talk about that in the question and answer session, but we met with the shipyards, we met with the owners, the potential owners and operators, we met with the naval architects to try and get an idea what pumping rates, what delivery sizes would be, and all that. So from that standpoint, we passed that knowledge on as much as we could, not necessarily to our competition, but the other folks, the other midstreamers, or the other fuel suppliers, or the other DEF suppliers in the marketplace. And again, whether that's West Coast, Gulf Coast, or East Coast. So look forward to some more questions. I like to say that, I don't know much, but I've got an opinion about everything. So to that end, I'll toss it over to David. Thank you all.
Yeah, thank you, Tony. David, are you able to drive? We don't see you on the video, I don't think.
So first off, I want to be mindful of time and everything. I'll try to flow through this quick. So I want to thank, Jim Munt and the Caterpillar team, and then of course the Waterways Journal team for inviting me to participate. Like Tony said, I think one of the big concerns has really been around the availability or the reliability of the supply chain in terms of, the reliability of the system. I think it's really threefold as you think about economy boat store. The first is, capability. The second is availability, and then the third is quality control. And so those three things really together kind of bring forward the reliability that we bring to the system. Jim, are you able to pull up those slides? I'm not seeing those.
Yes, sir. So I'm on page 3. So this is the map.
Okay.
Map capability slide.
Yeah. So from a capability standpoint, Economy Boat Store is fortunate to be part of a nationwide supply chain of fuel distribution. So, part of the Pilot Thomas Logistics portfolio, we've distributed millions of gallons of DEF. I would say we've distributed thousands on the inland waterways. We have coast to coast capability, and from a control standpoint, we've got sourcing, storage, and distribution squared away. Through some of our affiliate relationships, we've actually got connections with manufacturers of DEF as well. And so in various channels and distribution markets across the country, we've also got turnkey DEF storage and dispensing systems. So from sorry, getting a little feedback, but from a capability standpoint, certainly have that squared away. Secondly, from availability, Tony mentioned it, and a couple of the other presenters have as well. There's a couple of different specs of DEF available. One is the 32.5% blend. The other is a 40% marine spec that you often see. We're actually capable of supplying either one of those. From a marine standpoint, some of the OEMs have advised that they'd prefer the 40%. The 32.5% is certainly what you see on highway or over the road vehicles. So from a supply perspective, the 32.5 is much more prevalent. But if there's certain, tendencies to leaning toward the 40%, economy boat store and the other suppliers or midstreamers out there, certainly are capable or should be capable of providing that for you. In terms of kind of our delivery or transfer capabilities, what we've done up to this point are really on, drums or totes. So we primarily deliver via 55-gallon drums or 330-gallon totes. We do have with our fuel flats throughout the system, we've got a design, a bulk offering concept designed. We have not formally made that investment to make it available at this point. Some of that's kind of working with our customers to better understand what that demand forecast and demand profile looks like. But the investment's ready. The case, the concept, like I said, is designed. And certainly the efficiency of a midstream DEF delivery and transfer, accompanying fuel, lubes, water, etc., are certainly where we're headed down the road. Quality control wise, a couple of things Tony mentioned. I thought that was a great slide on kind of how sensitive this is to chemical impurities. So it's certainly a high maintenance product to some extent, but it does just require specified or dedicated tanks, pumps, hoses, and nozzles. So not a considerable investment. The stainless or poly tanks are required to maintain the integrity of the product. And so something to keep in mind as you're working with the OEMs or the manufacturers and the engineers on putting this equipment in your vessels. It does a couple of other just points on it. It does have a freezing point. Something to keep in mind, and the 32.5% product actually has a much lower freezing point. Some of our more northern locations, Memphis North as an example, 32 degrees, could come to play. So another potential benefit of that 32.5% option. And then lastly, just a couple of points. The useful life on the DEF is about 1 year. Avoiding direct sunlight, managing it in correct temperatures, and then from a consumption standpoint, for every 100 gallons of diesel consumed, we would estimate there's a 3 to 5% ratio of DEF for urea. All right, and so similar to the other midstreamers or suppliers that are out there, we pride ourselves at Economy Boat Store on making product available when and where it's needed most. We're obsessed with being reliable and kind of that rigorous focus on supply. And so we've got, deep industry knowledge and certainly a footprint that can make this product available when and where you need it most. So that's all I got. Jim?
Well, thank you, David, and thank you to the whole panel. What I'd like to suggest is if I can click down here, I left this session for Q&A. We only have about 7 minutes left of our time slot. Again, we're not debating. We are championing together, albeit some of us are somewhat competitors in some of our spaces that we participate. But we are collaborative members of the success of the industry. So we're very happy to provide some of the progress and work with customers, the stakeholders, the owner-operators, the naval architects, shipyards, in the supply chain. We all work together to try to be, advocating and championing overall the business that's conducted on the rivers. So there's 5 minutes left. I don't see any Q&A being posted. I probably should have, when I opened that up. Participants and audience, please add any in there. I did write down a couple with the time remaining. One of the ones I did want to ask, and maybe Mr. John Burton, are you still with us on the phone?
Yes, I'm here.
All right. So there was a question here. Maybe I could throw out your way. What is the consumption rate in the engines of the DEF? Do we have some estimates and some experience we could share
Yeah, and it varies a little bit by rating, but I think we're in general on the 5 to 8% of fuel. The rule of thumb guidance we've always put out and everybody's talking about is somewhere around 10% when you're looking at concepts for your main DEF tanks. The reality is you're burning a little bit less than that. So, again, rating dependent about 5 to 8%. And as we've improved and dialed in this process and these systems, the fuel consumption gets better. That better fuel consumption offsets the DEF usage.
Yes, thank you, John. Appreciate that. Now, Tim, I think you did touch on it during your presentation, but one of the things that, if you run out of the DEF, the urea component there for the after treatment system, what happens to the engines? Is there any derate or anything that happens, a problem in your operations?
It's a good question, Jim. So we're constantly monitoring the DEF tank level, and I believe that's an EPA requirement to monitor the level and the quality. And I can speak for MTU in this case. When we do run into a situation where we're too low on DEF, it throws an alarm code, but there is no derate to the engine. The engine continues to function as normal. Of course, the emissions footprint changes because you're not dosing anymore, and you need to deal with that alarm code. And in some cases, you have to self-report to the EPA and let them know that you did have this alarm and that you did fix the issue. But from an engine standpoint, there's no change in performance or anything you have to do with the engine side.
Thank you, Tim. And then one question, maybe for you, David, or for the time left. What is the typical pump rate? Do you have any experience? Whether it's a midstreaming or an initial fill, whether it's you, David, or Tony. What is the pumping rate that you're anticipating? How long does this operation take?
With the equipment that we're running, we can get about 60 to 70 gallons per minute. So you think the average delivery that we performed is, a little on the smaller side, probably in the 800 to 1,000 gallons. So, do a little bit of math there, not tough to figure out, but we're seeing 60 to 70 gallons per minute.
Okay, thank you, David. Well, with our 1 minute left, basically, I do want to thank the IMX team and this esteemed panel. Again, apologize about, I'm seeing a note here about network is unstable. Maybe the session will be posted as the IMX the team will do. And now with the panel members, myself, please come to us if there's questions we can follow up on that we didn't address. Encouraging you to reach out to us, and hopefully we provided a good education update and building a better world altogether. So thank you very much to everyone in the audience.